Okay, so the topic of data science is an overlap between a few fields. So this Venn diagram, it has some mathematical expertise, some hacking skills, how to be able to go through some data and just pull out what's important to you, and then business strategy, or just, depending on what your application is doing and trying to achieve, would determine how to take the data, run it through some mathematical models to generate new data that has some value to it. So let me just kind of at a high level go through what data science is. So it's the unification of statistics, data analysis, and related methods in order to understand and analyze phenomena that are going on inside your data. So some examples might be, if you wanted to look at data, let's say you have a website, something like a shopping website like Amazon.com, and you notice that people buy certain products. So when they start shopping for a certain product, you have data from the past, people who bought other products in the past, and you might notice that someone who buys a certain product that someone's looking for, there are similar products to that people buy. So you could suggest to them that people who are interested in the product you're looking for also buy this product. And that might increase the chance of a sale being made. So if your business is Amazon.com, which is selling products online, you might want to take data from the past, do some mathematical modeling on it, run some tools that analyze the data, and then tell the person, hey, you might want to buy this product. They could then look at that product, and then as they're looking at that one, you run another analysis of people who like that product might like another product. So it could kind of starts working in a cycle. So it's a hybrid of a lot of different already existing fields, mostly in computer science. And one of them is machine learning. And machine learning is where computers go and learn without being specific, explicitly programmed. So I'll just give an example of machine learning versus maybe OLAP, which is online analytical processing. So for example, if you know what you're looking for, let's say you've noticed that the sales in a particular quarter of the year, let's say the first quarter of this year are much higher than the first quarter of last year, and you go through databases looking for what happened during the first quarter of this year that's so special compared to last year. You might look at January, February, and March and compare that to last year's January, February, and March, and then look for a difference. And if you notice there's a difference in February, then you focus on all the different weeks in February. So that would be, what they sometimes call OLAP, online analytical processing. But if you really don't know what you're looking for, you're just looking at data, looking for any kind of pattern at all. You don't even know what you're looking for, but it starts telling you patterns. That's typically falls under machine learning. And then classification, then classifying, which products one person buys of the similar products that person would also buy. So classifying all this data together, it's classification stage. Cluster analysis is where you start grouping objects together into large clusters that have similar properties to them. So you might notice that if people who go looking for Adidas sneakers might also be interested in buying Puma sneakers because they're somewhat similar. Data mining is where you go through large blocks of data and you're looking for things that are related to each other. Those will most likely be done within databases, which we talked about in our database class. And then you want to be able to represent this data to somebody so they can see it. So this is kind of, there's no official definition of data science. It seems to change a little bit from year to year, but it's usually broken down into these 6 categories. And here's, again, kind of a Venn diagram of it. It's an intersection. Data science is an intersection of mathematical expertise, putting tools together to run programs on data, to generate some data, then asking, what is your business? Maybe our business is like Amazon, selling stuff online and recommending other products to people, and then we keep kind of going in a circle like that. Okay, so one example of machine learning can learn more of this later on in our course, is just one example of taking a bunch of data and trying to say there's some connection with the data. Suppose we notice that the height and the weight of various people, suppose we just took the height and the weight of people and plotted them. So a person who is, I guess this is in inches, 68 inches would be what, 5 feet 8 inches. And maybe they weighed, one weighed 120 pounds, one weighed 140 pounds, one weighed 100, it's like 55 pounds, 165 pounds. So these are different people, different heights and different weights. Now suppose we didn't know that there's a connection between height and weight. The taller a person is, the more likely it is they'll weigh more. Suppose we didn't know that. We could take all these points and say, is there some kind of a connection? So what kind of is the connection? Do you see any connection, or intuitively, is there a connection between height and weight? Like one goes up, as one goes up, the other goes down? Or?
No, it's proportional.
Okay, so we can kind of see that the points are kind of going like this, right? So suppose a new person comes along and I tell you what their height is, and I ask you, can you guess what their weight would be? What could we do with this data? Well, what we could do, so yeah, any ideas? Well, what could we do with this data? Suppose we know this, from, these are people from the past, and now a new person comes in, and we know their height, we'd like to guess their weight. Or if we knew their weight, we'd like to guess their height. So we're trying to make the point, we're trying to take our data and show that there is a correlation between height and weight. There's some kind of a connection. And if we could figure out what that connection is, we might be able to use that connection to predict someone's weight from their height. So what can we do with these points that seem to be moving in a direction like this? Not a perfect line, but. So there's a topic called linear regression in statistics, mathematical statistics, where we'd say, all right, we kind of can see there's a line going this way. Maybe we could draw that line. Maybe we know the y-intercept and the slope of the line. Now, how would you get a line from these points? What would be the definition of a good line? Like I said, maybe in a later lecture we could actually write the program that would do this, but just what would we be kind of looking for? What property would this line have to have?
Straight line?
Well, yeah, it's going to be a straight line, but besides being a straight line, like, so what if we put the line like over here? Well, that line's no good because most of the points are below it. Okay, what if we put the line over here? That line's no good because most of the points are above it. Where would be a good place to put the line?
In the middle.
In the middle. And what's the definition of the middle? Like, so what we want is the distance that each of these points are from our line. If you add them all up, it should be as minimal as possible. Right? So there's methods in statistics we can go over later on about how to pick the best possible line. But if we did have a line that was, kind of right through the center of the point, of all these points, we could then answer questions like if a new person showed up and we knew their height, we could guess their weight. And we could say to them, people of this height usually are this weight, something like that. So that's where we're taking data from the past, performing a mathematical operation by coming up with a line that best fits these dots, and then using that line to predict things about new customers. So that's one type of machine learning technique called linear regression, which linear regression was in the field of statistics way before computers were invented. So it's an old field. It's just now we're using computers to do that. Okay, now suppose this was, suppose somebody noticed in a population of people, they're trying to guess based on height. You're trying to guess if the person is male or female. I forget where I got this example, but it's probably European because heights are in centimeters. Well, are heights in centimeters in India too? Mm-hmm. Is this?
Yeah.
Okay. All right. So this. So yeah. So most likely, this example is not an American example. But anyway, so what is 180 centimeters? Anyone know how tall that is? In feet?
I think like 3 feet.
3 feet?
No. Wait. About like 5 or 6.
Okay.
Yeah.
So basically, suppose somebody just started looking through data of heights of, so suppose you had heights of different people and you knew if they were male or female, and you notice almost, at a very high percentage, people who were over 180 centimeters were male. And then the ones less than that, we have a second question. What's your weight? And if you're over a certain weight, you'd be male, but if you're under a certain weight, you'd be female. What you could do is you can try different values for here and here, and keep moving the values back and forth until the model that's using to predict it matches or optimally matches the data you have. Not to say that this is a great way to predict, but you could take your data and then you decide, this is my mathematical model. I'm going to look at height first and then use something else as a tiebreaker later. And I'm going to try to find the optimal number here and the optimal number here that gives me, that's not going to answer correctly every time, but maybe this chart could answer it correctly 95% of the time. And then you could use that, again, for guessing at new data. That's kind of a silly example. But it's another, so this is another topic in machine learning called decision tree models. Okay, so what do we want to do with, like I say, today's just kind of an introduction to data science. But what are some things we'd like to do? We'd like to take data and be able to answer questions about it. And one of the things we might want to answer is, are there any abnormal patterns in your data? So for example, if you're using a credit card, you're purchasing with a credit card, somebody goes to make a purchase, you don't know is the credit card, did someone steal the credit card and they're buying something that the person who owns the credit card normally wouldn't buy? And maybe we could look for patterns like there's a certain price range a person keeps buying stuff at, and then this is much more expensive or much less expensive, buying a candy bar and they never bought a candy bar before. But it's not like someone's going to steal a credit card and buy candy, right? But anyway, so buying something outside of your normal price range might be something that our data science could say, hey, this might not be that person. Or outside your radius, this one I get a lot, outside of the radius where you purchase stuff. So I go on vacation to Florida and I buy gas, one of my credit cards won't let it because they go, you don't usually buy stuff in Florida. So they know I'm outside of my area. So they, again, that's, looking at all the data from all the purchases and just looking for patterns that aren't normal and stopping it. And then outside, gap of time between purchases. So they're looking for all the data about your purchases, where you make your purchase, what the amounts are, how much time between purchases. So sometimes if someone steals a credit card, they start making a lot of purchases right away. And if you're known for not purchasing all the time, you make a couple of purchases a week, they might notice that's something wrong with the pattern of your data. So. Okay, then if your business logic, so like we said earlier in this Venn diagram, we have some mathematical models looking for stuff like mathematical patterns. Is it outside of your normal statistical range for buying products? And then we have technology that's going to read the data that implements that. But then coming around to your business logic, would we want to go back to, depending on what the business you're running, might want to have questions like, to bring in new customers, should we have a 25% off sale, or should we have a buy one, get one free sale? So buy one, get one free is kind of like 50% off, but you have to buy 2 things. Whereas this is 25% off and you only have to buy 1 thing, and which one's better? It depends on, I don't know, do you have an idea what would be better out of those 2 in general? Without even knowing what the product is?
Buy one, get one.
You like that better?
I like 25%.
25, okay, because, well, the advantage of 25% off is you only have to buy 1.
Yeah.
This one you have to buy 2, but you get 50% off. So which brings in more customers. And you might not want to do both. Do you want to do both?
I think buy one get one free is good for like big family.
Oh, yeah. So but I guess what the question is, they're like, we're chatting about what's better and we have a disagreement, right? So the question is, could you look at old data of when we used to do both and see which one brings in more? And I know companies like Facebook now are hiring people with sociology degrees. What do societies, what do large groups of people think? And they try to answer questions like this. Why would someone like this over this? But a lot of times you could just look at old data and just see what happened in the past. And again, one thing we're doing is very important in data science is we're trying to predict the future looking at data from the past. So if there's something wrong with the data from the past that doesn't apply to the future, then it's no good. But we're usually looking at data from the past to predict the future. We'll look at, in the past, when we did a 25% off sale compared to buy one, get one free, which one brought in more people? Maybe we never had a 25% off sale. Maybe we had a 20% off sale, which is closely tied to 25%. And maybe we had a buy two, get one free. So we're now looking at data, but then mathematically trying to say, how does it tie to our current question and come up with an answer. And another type of question could be if the stock price of Coca-Cola goes up, will the stock price of Pepsi go up or down or remain the same? So what would be intuitively, what do you think? So the stock price of a Coca-Cola sells soda, Pepsi sells soda. So if one went up, would you think the other one would go down, up, or stay the same, or any guess? There's really no right answer, but
the stock price, not okay.
yeah, the stock. So in other words, what would cause stock price of the soda company to go up? Maybe
the sales go up.
Yeah, but let's say maybe government tax on soda. There's a big soda tax, right? So maybe if they lowered the tax on soda, that could cause the stock price to go up. Or if they raise the tax on soda, that could cause the stock price to go down. Well, then Coke and Pepsi would go up and down together. But maybe if one went down, maybe there was bad news about one, that could cause the other one to go up, right? So, or maybe they're unrelated. We don't know. But what we could do is look at the past. Look at data from the past. Every time one went down, what did the other one do? And if the other one went up 70% of the time and went down 20% of the time and 10% of the time it stayed the same, then we'd say, well, sometimes it goes up, sometimes it goes down, but usually it goes one way. That's what our data from the past has told us. So that can help us later on if we ever decide, and there's financial applications for big data. It's probably the biggest application is in the financial market. Suppose we noticed there was a correlation between Coke and Pepsi, that every time the price of one of them changed, the other one changed in the opposite direction a little bit later. Suppose we're looking through all our data and we notice that pattern shows up not 100% of the time, but 70% of the time, more than it doesn't happen. Then we think to ourselves, every time the price of one goes up, the other one will shortly after that drop. Maybe, or if the price of one went down, the other one would go up. Maybe we should invest in the other one right before the price change and get some profit off of that. So that's a huge application of hedge funds, which they now call fintechs, financial technology companies. Just look at old data and see correlations between the data moving and then make predictions of what to do with that. Okay, so you've probably seen this when you go on Amazon.com, and it says customers who bought this item also like this item. So how would this be calculated? How could Amazon know this? So what data are they looking at? So when people buy stuff online, they take items and put them in their imaginary cart, right? You put 3, 4 items in your cart, and then you hit purchase, you give your credit card, and then they mail it to you. So now they know these 4 items were bought together by one person. So how could they notice, so you have items A, B, C, and D that you bought together. Someone else buys A, B, C, and E. Someone else buys A, B, F, G, A, B, and all of a sudden A and B seem to be getting bought together a lot. How could you look through large databases that have all the carts and all the items in the carts? How could you notice 2 items seem to get purchased together a lot? What would you be looking for? So maybe what we could do is in our SQL statements, maybe we could write some SQL statements that would find this stuff. But it's not as easy as just say, well, yeah, how would you go looking for a big collection of products to know that 2 of them seem to get purchased together a lot?
I'm sorry, what?
So suppose you had the history, you work at Amazon.com. You have the history of all the people who've made purchases in the past, and you know all the items that were in that cart. So they purchased all these items together. How could you know that 2 particular items seem to get purchased together a lot?
You just look at all of your past data, like you just, and then if 2 items happen to be bought together a lot, then you just put it on suggestions.
Right, but what I mean is you could look at one item and then say, go through all my tables looking for anyone who bought this item. So you'd be pulling out records for everyone who bought that item. Then you'd run another query saying, what are the other items they bought, which is going to return a lot of data. Then you have to start counting up every item in that list. How many times was that item bought, and then take the one with the highest number. That's it's computationally intensive, so we kind of need mathematical tools that can do those operations kind of quickly. But yeah, that's how we would end up doing that.
Professor, can
Yeah.
we just like maybe research similar items and just put it on the list instead of doing that?
So that's kind of an interesting point. So now you're saying as the program, this is really the difference between machine learning and OLAP. You're kind of saying, I know these 2 products are similar. You might think Coke and Pepsi are similar. Let me do research on Coke and Pepsi.
Yeah.
But what we'd actually like to do, and I kind of have a note here, talk about the beer diapers on Friday story. But so let me tell you. So I'm not. So here's the thing. It might be so. Some people might know 2 products should get bought together, and you can start doing queries. Do these 2 products get bought together? And you might find the answers yes. You might find the answers no. But what if 2 things you would never expect to be bought together, suppose they were bought together, you wouldn't know to go looking for it. So machine learning is kind of goes searching for stuff, it doesn't even know what it's looking for, and it finds results. So what you're saying is good, that you can intentionally target, does beer and potato chips get bought together? Because you think they probably would, and then you find out, yes, it's true. But what if you went looking for 2 things that you would never think are bought together and still found it? It'd be important to know. So there is a story, you can Google this. It's the Walmart beer and diapers on Friday story. So the story goes like this. And a lot of people say this is not really true. But Walmart did a data science observation of all the people who come into their store, not buying online, and notice everything they put in their cart. So the cashier rings it up, so you know all these items are grouped together into a purchase. And they noticed that on Fridays, a lot of customers would buy beer and baby diapers together, which you would never think makes any sense. So the reason why this is a good story is beer and diapers normally wouldn't go together. But they noticed this, and then, I don't know, they give some explanation, like a lot of people work from home on Fridays, and they get diapers, and they buy beer.
It kind of works. Like if you're a middle-aged dad.
That's the explanation. They were saying that a lot of middle-aged dads are working from home on Fridays, and their wives want them to get diapers, so they buy some beer. Yeah. So then, and the story goes that Walmart noticed this, and you would never know to go looking for it. You have to write algorithms that read through the data that find this for you. And then they decided to put the beer and the diapers in the same aisle so the customers would be happy. So again, I'm not 100% sure if this story is true, but it's an example of something you might not go searching for. You might not say, oh, I think people who buy beer also buy diapers. Let me check if it's true. You wouldn't know to go looking for it, but you need to be able to find stuff that you don't even know to go looking for. So yeah, so I kind of put that note there. So yeah, so these are called clustering algorithms, where you're just taking massive amounts of data, writing them out to disk drives, even with multiple copies, so you can start searching. Take this product and look for all the things that were bought with it, then count up all the totals, sort them, and then run them to the top of the list. There's a lot of computation in doing this to eventually find it. And what value does this information have? Well, maybe you can put these two items in the same aisle and have more sales. In the end, that's what it all is, have more sales, right? So, okay, so yeah, we're answering specific questions. Data science can be used to answer specific questions. What will happen to a stock price next week? Will it go up? Will it go down? Will it stay the same? You could look at data not only about that stock price, but you might start to notice connections between one company and another company. If one goes up, the other one goes down. If they're in the same field, they're in the technology field, they all go up and down together. If they are in the food field, like soda companies, maybe one goes up while one goes down. So you could look at old data to predict new data. What would stock price be next week, tomorrow, 5 minutes from now? Which stock is the best to buy next week? So you could do a calculation on all of them and pick out which is the best one to buy, because you only have enough money to buy one. And then so in the field of finance, there's a thing called derivatives. Have you ever heard the expression derivatives in finance? So you have a stock price, but then you have a derivative. That would be something that you can invest in. You buy it, and the price will either go up or down. But a derivative could be like a stock option, which is where if the stock goes up, what they call a call option will go up a lot more. If the stock goes down a little bit, a put option will go down a lot more. So you get the same gain and loss, but at a much bigger amount. So if you could predict if a stock is going to go up or down, and you don't have to get it right 100% of the time, but if you can get it right 70, 75% of the time, that would be very good, because you could make a lot more money 70% of the time and lose the money 30% of the time. You'll come out ahead. Yeah, is there a correlation between two stocks? Do Adidas and Puma sneakers go up and down together? Do Coke and Pepsi vary? One goes up, makes the other one go down. How could you know this stuff? You could run data science analysis and look at the past and look for patterns. Okay. So some popular tools, I don't know if you'll be able to see this, some popular tools that read through the data and tally up results. Starts to look like, so this is 2015, 16, 17. Starting to look like the language Python is taking over the language R as an analysis tool for tallying up how many times you see an item. And SQL, the programming languages used in databases, is the third most popular one. But it looks like, yeah, Python and R are probably the biggest ones that will, and they can be written to log into a database, issue SQL statements, and rearrange the data so it can do counting and analysis on it. And Excel is still popular. I'm a little bit surprised MATLAB is not in this list. But, so these are from the technology part of the world. These are the tools we use. The programming language R has a lot of statistical functions you could call. So you can gather up a whole bunch of data into a matrix and then ask a simple question like, what is the mean, what is the variance, how far away from the mean? And they'll answer those questions pretty quickly. SQL, as you know, just reads through tables and pulls out data that you're looking for. And Python is now, looks like, it's just passing R now in popularity in the big data field. So kind of the overall process is a little bit of a loop. So the world keeps generating data. You know, people log into Facebook and they enter tweets and they upload their tweets. And then, or people enter pictures or You could look at tweets and say, what are the topics these people are talking about, and then you want to know what topics are trending, right? So you log into the internet and it says, this is the topic that's now trending. So what they're looking at is all the people who are making comments, and they're looking for words in those comments, and to see if those words keep repeating a lot, counting up how many times the words show up, and then they know that's a popular topic. And then they show you all the tweets about that topic, because they think that might be what you're interested in, because the rest of the world is interested. So the world is generating data. We collect that raw data in an unformatted way, and then using R and Python and Hadoop, big data, we organize the data in such a way that we can do some statistical analysis on it. We might clean it up a little bit, and then we do our analysis on it, which generates maybe counts of how many times a word shows up. And then make new data, clean that data up again, and then start saying, oh, anyone who bought this product also buys that product. And we keep making some new data. So we could go a couple of times around here. And then eventually we run it through our algorithm. Once we have all our counts set, we can make determinations like, yeah, people who buy this product also buy that product. And we visually communicate that back to somebody. And we output that, and we say this is a topic that's now trending, and then we tell the world this is the trending topic. That causes more people to start watching that topic, which generates the whole cycle again. Yeah, so like I said, this is just an introduction to what is data science, but it's basically the idea of we now have so much data, right? All these Twitter and Facebooks have over 1 billion users now. The 1 billion users are putting new data in every day. And we like to look at that data and make decisions about what are people talking about, what do people want to buy, that kind of stuff.